Welcome to our class. This week we will look at databases, the MySQL database, and phpMyAdmin, the software that is used to administer the database. Databases are a collection of data. A relational database uses a table which consists of rows and columns to organize the data. We also have a key system which allows us to build relationships. Some examples of relational database: MySQL, Microsoft Access, SQL Server, and Oracle. Most of the databases used in the industry are relational. However, it is possible to work with a non-relational database. A non-relational database can be a flat file, such as a comma-separated value. A spreadsheet is very similar to a database in that it does organize data. We also have a hierarchical system, such as the folders. This essentially is another way of organizing data. It is not relational. We also have some newer unstructured database types, such as NoSQL and the way that Google organizes data. So why do we need a database? Well, for example, if you were to register an account, you would need to set up a login, an email, a password. That would need to be stored somewhere so that when you access that page again, those credentials can be checked. If you were using that account for commercial purposes, such as Amazon, it would also store your information and your past purchases. All of this would be stored in a database. We also have the ability to dynamically generate content on the web page for a database. Not all web pages are hard-coded, meaning that someone has written all the HTML. Most of our large databases, such as Amazon and Facebook, work with a back-end database where the developer writes a template and the data is stored in the database. When the page loads, we see that data via the template. So how do we set up a database? The first thing we do is we need to identify the elements, subdivide the elements into the smallest parts, identify the tables, and assign column headings, which are called fields, identify primary and possibly foreign keys, review the structure, and identify indexes. We will not be working with indexes in this course. So let's take an example of how we would identify the data elements and then subdivide them. Here we have a vendor address, which contains a street, city, state, and zip code. It would not be efficient to store all of this in one field in a database, so we would break it up into component parts, such as the street number, city, state, and zip. Next, we would identify tables and assign column headings, which are also called field names. So we might have a table that is specifically related to vendors. It would have an ID, a name, an address, etc. We might also have another table that contains invoices, which would have an invoice ID. It would also have a vendor ID, which would relate to the characteristics of the vendor, who the vendor is. There might be another table, the individual items, that might be stored in a separate table. And we would need to uniquely identify these headings in a meaningful fashion. We would next set up keys. A primary key is a unique identifier for every row. Every table has a primary key. If it is not something that you have identified, you can use an auto number, an automatic number starting at 0 or 1. You might also need to set up what are called foreign keys. A foreign key would have the same heading as a primary key in a different table. and therefore we can draw some kind of a relationship between the two of them. You might also need what is called a composite key, whereas each record is uniquely identified by two different keys. There are three basic types of relationships that can exist between tables: a one-to-one, a one-to-many, a many-to-many. And these relationships are built upon the primary and foreign keys. So in this example, we have a one-to-many relationship, which is the most common type of relationship. So on the left, we see the vendors table, and there is a vendor ID. On the right, we see an invoice table. So all of the unique invoices would be stored here using the invoice ID. There would also be a vendor ID, which would be related to the vendors table so that we could identify who the vendor was, their address, phone number, etc. Because one vendor can be linked to many invoices, we have a one-to-many relationship. We also can have a one-to-one relationship. So in the table on the left, we have the employees table. And this is where you might have information such as their ID, first name, last name, etc. However, if you were to set up a table for photos, you would relate the photo to the employee by using the employee ID field. So there would be one-to-one relationship here, meaning one photo per employee. In databases, we have this concept of referential integrity. Referential integrity is the enforcing of the relationships between the tables. And essentially what this is saying is that a table with a foreign key cannot have a value that does not exist in the table with the primary key. So here we have two tables. On the left, we have the vendor table. So in this table, we would have many rows of vendors. They would all have a unique ID. On the right, we would have a table full of invoices. Each invoice has its own unique ID, and it would be related to a vendor. When coding in the values for a new invoice, you would give it a new ID, but you could not give it a vendor ID that did not exist in the vendors table. To prevent these types of errors, we have what is called referential integrity. You always want to make sure that your data is accurate and not redundant. So let's take a look at an example of a relational database. Here I have a table for members in a college. And in this table, I have some field names: ID, status, L name, F name, address, city, state. Very typical type of table that you would have in any organization where everyone has an ID and we store their demographic information. We have 3 rows. Each row is uniquely identified by an ID, and they have to be unique. You could not have the same value in this table. In our 3 rows, we have common columns or fields. We have a field for their status, for their last name, for their first name. So this is what we mean by a table. We have a row-column relationship. So columns or fields identify the data, and they are related to each other somehow. The rows are groups of related data, and the table is essentially a collection of rows. Here in the same table, we have the ID field, which is set as the primary key. It is a unique identifier for each row, and it allows us to prevent duplicate rows. You could have 2 people with the same name living at the same address, but they could be different people, and therefore they would need unique IDs. Let's take a look at these 2 tables to understand how not to lay out a database table. In the first table, we have the college members, which we have already looked at. Now, supposing each one of these members was going to be assigned a parking permit, we would also have a table with parking permits. And if you look at this table, you see the permit ID, which would be a unique identifier, a primary key. However, in every row, we have repetitive data. We have the status, the last name, the first name, the address. One of the reasons why you use multiple tables in a database is to prevent redundancy or repetition of data. It is much easier to update data in one place rather than in multiple locations. And what we would do is we would create a relationship between those two tables so that we could query that data and return the name, address, etc. of the person who owns that parking permit. So let's take a look at how we would create an efficient table relationship. Our top table is the same with our primary key. Now in our parking permits table, no longer do we have the demographic information, but we have, as we did before, the permit ID, which is the primary key. We also have another ID, and that matches the ID of the college member, and that would be the foreign key. I also have another field, the year. Therefore, if you wanted to find out who owned an ID for a parking permit, you could query this table because it is related to the college members table. You could pool that information together in a result. So this table at the bottom would be an example of a result set generated by an SQL query. Although this is a table, it is not a persistent table, meaning we did not create it. It was dynamically generated by an SQL query. So this is the whole reason why we store data in databases, because we can find out a lot of information rather than hard coding related information. We can query the database and dynamically generate a result set that we might need to use. There is some database structuring terminology that you need to be aware of. First is this concept of normalization. You might hear it referred to normalizing a database. And this is the process of reducing redundancies, which avoids duplication of data. You might hear some references talking about 3 normal forms, others talking about 5 normal forms. So we have this concept of a normal form as a way of measuring the levels to which a database has been normalized. So it's a process of organizing data, which applies to how we create tables, establish relationships in order to eliminate redundancy and inconsistent dependencies. The first normal form has to do with eliminating repeating groups in individual tables, meaning that it might be more efficient to create separate tables which consist of related data rather than trying to store a lot of data that may not be that closely related into one table and identifying them with a primary key in order to build a relationship between the two of them. The second normal form has to do with creating separate tables for values that apply to multiple records, and you can join these, relate to them with a foreign key. So here's a normalization example. A customer address change is much easier to implement if the data is only stored in the customers table and nowhere else. Eliminate redundancy of data, which not only occupies space, but creates problems with maintaining that data. The third normal form is eliminating fields that do not depend on the key. So here again, in the table, the data should be closely related by eliminating values that might not really be needed there and putting them in another table would be adhering to this third normal form. Structured query language, or SQL, pronounced SQL, is the language for manipulating data in a relational database. Every relational database uses SQL. However, that SQL language might be a little different among the different databases. SQL was developed in 1970, and it is implemented differently in databases such as Oracle, SQL Server, DB2, which is an IBM database, and here in MySQL. However, for the most part, the language is pretty much the same. There are many SQL commands, and they can be organized under different headings. We have one heading, a data definition language, and these are commands that create and restructure database objects, such as a table. We have the ability to create a table, to drop a table, which means delete, and to alter a table. We also have what are called data manipulation language, and this is where we are going to be focusing the most in this class. This is how we manipulate the data, query the database in order to produce a non-persistent table. We have a select, insert, update, and delete statements. We also have data control language, and this helps us to administer the security of the database, creating users and granting and revoking. So MySQL is an open source relational database management system. It is used for developing web-based applications and is commonly used with PHP. It is non-procedural, meaning that the database will read the whole query and then execute it. It does not execute it as it goes. It is free, and it is currently supported by the Oracle Corporation. Many of the web applications we are commonly used, such as Facebook, Wikipedia, and Google, actually use MySQL database. So that shows you that this is a very powerful database. Also, content management systems such as WordPress also are built upon the MySQL database. phpMyAdmin handles the administration of MySQL. There are other tools such as MySQL Workbench. However, I am using phpMyAdmin because this tool is available on the web server to handle your database. It is included in XAMPP. It is free software written in PHP. It is a web-based interface, so you're doing everything in a browser. And as I said earlier, it is included in most web host control panel. You can find more information about phpMyAdmin at its homepage here, and you also have this ability to try a demo, and you can actually play around with it, creating a database, tables, etc. on the web without doing any harm to anything.